My name is Ken Lynch, and I'm Director of Marketing at Senate. I'd like to thank you all for taking the time out of your day today to join our webinar titled Using LoRaWAN to Automate Water Utility Data Collection and Deliver Contactless Smart City Solutions. Before we get started, I've got a few prep items to let you know about. By default, all participants are on mute. There is a chat box available at the bottom of your screen to type any questions to the host. This should only be used if you need to communicate issues with your connection, and we'll do the best that we can to support those. There's also a Q&A function, which allows you to submit questions. We'll be answering as many of these as we can during the webinar, but for those that we don't get to, we'll follow up as soon as possible after the webinar is concluded. This webinar is being recorded, and it will be posted for future viewing. And we're also going to be emailing a link for the playback of the webinar to all registrants. Now I'd like to introduce you to our speakers. Today you're going to be getting different perspectives and learning best practices from leading companies across the LoRaWAN ecosystem. Presenters for today's webinar are Remy DeMerle, Marketing Director for the LoRa ecosystem at Semtech, Andy Honeycutt, President and Chief Consulting Officer at MeterSys, and Dave Gendel, CTO and COO at Senate. A quick review of today's agenda before we get going. We're going to open up with an introduction to LoRa and LoRaWAN technologies, a market overview, and a review of the growing ecosystem of companies in the water metering, water management, and smart city markets. And this will be presented by Semtech. This will be followed by a review of the requirements for designing and deploying LoRaWAN networks for large-scale device deployments. And new engagement models available to utilities and municipalities presented by Senate. And lastly, presented by MeterSys, a detailed look at the evolution of AMI, municipal customer case study illustrating the decision points and value driven by LoRaWAN solutions, and the opportunity that municipalities have to leverage LoRaWAN connectivity beyond AMI for a variety of smart city solutions. And with that, I think we're ready to get started, and I will hand it over to Remy.
Thank you very much, Ken. It's a pleasure to be invited as Semtech for participating in this webinar. We will discuss about LoRa in terms of technology features. Also, we will cover the topics of the market adoption, and we will also give more insights about what is going on in this low power wide area network that may be new for some people, but I will explain more in details. So the benefit of LoRa is today to be a radio technology that has been acquired by Semtech in 2012, and that is used today by millions of devices over the world with the available free license spectrum. In US, it's 915 megahertz. And for, I would say, what has been changed compared to some decade ago, where developed first RF and other protocols for connecting meters, we have today the capability to have very long range and to cover with one antenna, one so-called gateway, a very large area, more than 20 miles coverage. It's better than a cellular antenna. It allows also to have penetration in buildings, but especially for the case of metering, it allows you to connect meters that are installed in deep underground and 60, 90 centimeter deep in water pits that sometimes can be covered with a metal plate and makes it more difficult for radio to penetrate. The LoRa also allows you to have a very good consumption, a very good power trade-off for long range. LoRa simply means long range, but it also has low power. And that's why today LoRa is a key technology from the low power wide area network. The lifetime of the water meter is a criteria of importance. Water utilities today in North America require 20 years. In Europe, it's likely more in the 15 to 16 years. But with that technology that consumes very less power, you can achieve on a daily basis 2-3 transmissions a day and still remain for 20 years, which is a very good trade-off for, I would say, the long range, the deep penetration, and the lifetime. That's the key criteria for choice of a technology. But there are other benefits, like the capacity. With one antenna, you can have millions of messages per day on a 24-hour basis. And then you can have eventually a scale up of this capacity by simply adding new gateways. That's a benefit also of the technology. An affordable gateway is in the range of $1,500 to $2,000, and that's for a macro outdoor gateway. There are also other range of devices and gateways for indoor, for also a shorter range if necessary to adapt in buildings. But here, for the purpose of metering, that's a very affordable infrastructure. Even more, you can have public/private/combination of both, and the Senate will explain very well how this can be enabled. So affordable, open protocol, easy to use, and for an affordable cost. The other benefits that we have in the technology are the bidirectionality. Oh, sorry, I was quick. Yeah. Bidirectionality allows you to, for example, to control a smart valve or to ask for the credit of a prepaid water meter in some countries. That's important. So it's a protocol where you can have uplinks, downlinks, at the difference of Sigfox, for example, which is another LPWAN technology where the number of downlinks is limited. It allows also to have a good interoperability. Why? Because the LoRaWAN protocol, which is the network protocol above LoRa radio and specified by the LoRa Alliance, is something that is shared by more than 500 enterprises and ensure interoperability with one unique certification. Security are also very important for IoT, and here with LoRaWAN, you have two layers, two keys, one network key and one application key that ensure all the content it remains safe and protected. Can be transported by any operator, but only the payload content will be decoded by the application level. Last but not least, a geolocation without GPS is possible with the LoRaWAN network, which can be interesting for example, for an inventory of assets, even if it's fixed devices like smart meters. So the view of the stack explains the difference between LoRa and LoRaWAN. LoRa is technology of Semtech. It's also multi-source supply. Multi-suppliers exist for LoRa devices, LoRa modules. And you have LoRaWAN, which is an open protocol, again, specified by the LoRa Alliance. You have three classes of devices. The class A is good for smart meters. They can emit when they need uplinks and remain open for two reception windows. Rest of the time, they are in sleep mode. They consume much less power. Class B, they are more frequent wake up. And class C, they remain continuous. This can be used for class C, for example, for street lighting, when you have when you need a good network latency to switch on or switch off. Yeah, but the adoption of LoRa It's important to compare with other networks and network technologies such as the NB-IoT, LTM for cellular or Sigfox. By far, we will see that in comparison from analysts. But the number that we can share today from Semtech is more than 800,000 LoRa-based gateways have been used and connected over the world by the end of 2020. That's the prognosis. And we have more than 145 million of connected devices, which is by far much higher compared to Sigfox numbers or NB-IoT and LTM. In terms of countries, a recent study of IoT analytics said that for NB-IoT, there was at the end of 2019, 92 NB-IoT networks and 35 LTM networks. So that's much less compared to LoRaWAN. The, I would say, analysts here make a comparison between the technology and predict a large, I would say, for the next 5 years, a large success of LoRa and LoRa-based devices to represent much the highest part of the LPWAN connections. This we should grow between 2020 and 2025 in terms of total installed base. Asia Pacific is the leading region with more than about 60%, and this should be expected to maintain. But North America, Europe are accelerating very fast. Utilities is definitely the largest market segment for LPWAN. Other analysts than Omdia, formerly IHS, account for 35 to 39% of the LPWAN installed base. Gas and water metering are the leading use case. Now we will see with Senet the different applications that can be used with LoRaWAN networks. But before, just to represent the large ecosystem, you have for the utilities a very good, I would say, view of different devices from different companies. For smart metering, you have water meters from Neptune, Mueller, available in US, plus Zener, Arad, and gas meters from Ayud, Coldcard, also from Mesura. Electricity meters from Vision Metering are also available in the market. You have several other devices that can be used for retrofit or for also ancillary products, such as gas or water leak detectors. You have also pressure, temperature, and soil moisture, water quality control that can be made by different companies for LoRaWAN. For smart city, numerous players exist, from air control with Decent Lab or Metos from Pessel, street lighting with FlashNet and Butia and Wellness, also rodent trap, KST, and Woodstream can support the applications like that. But one of the most successful application is smart parking management that can be enabled by PNI. And now all these devices have been also in the catalog of Senet and can be connected with their network. Dave, the floor is yours.
As Remy said, Senet is a LoRaWAN core network platform and network operator in the United States. We've been part of the LoRa Alliance since its founding and deployed one of the very first public LoRaWAN networks in the world, slightly before the founding of the LoRa Alliance. My name is Dave Schendel. I'm the CTO of Senet, also a board member of the LoRa Alliance and the chair of the Regional Parameters Working Group for the LoRa Alliance. And Senat's vision in this space has been consistent over the many years now, the several years that we've been working through this, to bring whatever tools are necessary in order to enable the really exciting solutions that low power wide area IoT bring into the market. So key to that is the core technology and the core protocols that Remy just mentioned. So from an operator's perspective, when we looked at these technologies in 2014, and there were various ones that were starting to compete at the time, there are a few things that really were very important for us in making that decision. And I think those have stood the test of time and represent the key attributes of the technology that make it so attractive and so valuable as we look at solving these very interesting IoT solutions. So certainly the open standards-based communications protocol is absolutely foundational to being successful in the market. And really LoRaWAN, compared to many of the other unlicensed solutions that were poking up their heads in the 2014 timeframe, really took a leading stance around that. And that open standard enables the networks that we build that support LoRaWAN to support a huge range of devices and solutions that are out there. By the device becoming compliant with the LoRaWAN protocol, they can rest assured that they'll be able to operate with any of those hundreds of LoRaWAN networks that are being deployed around the world. And that is very, very valuable to us as well, because as we're looking to take advantage of the networks that we deploy, we want to support all comers. Of course, those networks need to be cost effective. Of course, they need to be secure, and the LoRaWAN protocol is really instrumental in that. The networks that we build are focused on carrier grade capabilities. So they need to be resilient. They need to be able to support the kinds of applications that support critical infrastructure like metering and other utility applications, as well as smart city applications. And of course, from a Senate perspective, we saw the opportunity here to bring this to the market in a cloud platform. LoRaWAN technology itself is most well suited for a centralized management and control plane. Its data plane is also centralized, so cloud deployment is one of the most obvious ways to take advantage of that, and the scalability to support hundreds of millions and billions of devices as they get rolled out. And Ken, can you advance my slide, please? So when Senate looks at the opportunities for network design and design for utility and municipal networks, there's really a three-step process that we go through. We're going to go over that very, very quickly here. How we design that process, how we design those networks, how we look at bringing additional applications and solutions onto those networks once that is there, and then how we follow that up with possibly densifying those networks as it's required as the solution scale grows. One of the things that's very interesting and important about LoRaWAN compared to many of the other technologies out there is that you can transition the way that networks are designed from a coverage model, which is how you start out to get the most coverage possible, to a capacity-driven model, so that you can continually increase the capacity of the deployments underneath those networks. The design and build process has 4 major steps. Certainly we start with the design. This takes input from our metering utility customers around the locations, the service locations that they're providing service to their customers at, as well as any potential assets that can be leveraged to deploy network on top of. When Senate looks at these problems, we really look at it both from the ability to take advantage of traditional commercial assets, so think radio towers, billboards, rooftops, as well as the natural advantage that the utility or municipality can bring to bear by leveraging their own assets for a lower cost of deployment and operation. So we combine all of that, all of those inputs together, and we run through a design process. That design process then iterates into what we call acquisition, and acquisition is the formalization of the leases, the rights of access, zoning and building permits and those sorts of things. And of course, then the next step is actual construction. Once construction is complete, then we move to the verification phase to make sure that the network is going to meet the needs of the applications that are going to be deployed underneath it. So this process is fairly typical for commercial grade, carrier grade networks that are deployed out there. But for IoT, it's very important to realize that this level of diligence is very important when you're looking to meet the strict and stringent requirements of utility and smart city solutions. So once the network has been deployed and once the initial utility solution in this case has been deployed underneath that, now we look at how do we bring additional applications beyond that first application. And really we're going to break this down into two parts. And Andy from MeterSys will go through this in much more detail, but we look at the secondary and tertiary solutions that are still focused on the utility. So this may be additional metering applications. So if you start with gas moving to water or water moving to gas, but also the additional applications that many of those utilities can bring on top of the networks that maybe don't have quite the same scale as the metering deployment itself. And this could be infrastructure monitoring. So you can imagine wastewater management, groundwater monitoring, leak detection in the mains. You can also imagine even in electric grid utility applications, so monitoring line breaks, monitoring pole health or transformer health. All of these are fantastic LoRaWAN applications that can be delivered on top of the very same network that was built to serve that initial utility application. And it's really the capacity that's available in the LoRaWAN network that enables that. So when we do a deployment for a utility metering application, which is a very, very dense application, we're typically consuming only 1 or 2 or 3% of the total capacity of that network when that is completely rolled out. So there's a huge amount of opportunity to bring additional applications there. And then, of course, slightly different sales motion, but very, very interesting as well are the smart city applications. And those smart city applications range from everything from street lighting to, as Remy said, smart parking and pest management, waste management, on and on. And these are very interesting applications. Not all of them have the same scale as the utility metering does, but all of them are very, very important and interesting to the municipality in terms of delivering additional value to their constituents. Finally, once those additional applications have been deployed, we have the opportunity now to densify the network. And as I mentioned, we can do this really in two ways, one to provide coverage and the other one is to provide capacity. So we look here at a brief example. This is Washington, D.C. and 3 steps that we would take. The first starts with a downtown, potentially like a downtown city area, if you will. This is the Washington Metro on the left-hand side there. Enough density to provide metering in that solution. We then expand that to the entire cellular market area around that. So all of the towns, the feeder towns, the suburbs that bring into it, and finally densify that as utility metering and smart city applications start to be delivered against those. Again, this progression is very, very natural, and it's what Senate believes is the most reasonable way to providing network coverage and growing network coverage as we're bringing solutions to market together with our partners. Next slide, please. So, of course, once we've gone through that process, we have to make sure that the networks perform to the requirements that have been specified, and that's what Senate's core platform is engineered to do. Our core platform, again, cloud delivered, really focuses on 3 key areas. So application and end device onboarding and performance monitoring. So this is what the metering customer, for example, the infrastructure monitoring customer would see. That's how they bring their devices to the platform, how they activate them, how they get data streamed to the right back-end endpoints for ultimate value data delivery to their end customers, as well as identifying potential issues that are going on within the population of devices that they have. So one of the things that's very challenging in the massive scale IoT space is how do you carefully balance understanding where issues are that need to be actioned when you have hundreds of thousands, hundreds of millions of devices that are all out there in the field, and that's a key focus of our solution. Of course, the complement to that is on the network planning and performance monitoring side. We'll talk a little bit more about why these tools are so important, not just to Senate, but to our partners as well. Of course, this is related to how do you do ongoing management of that network. So identifying sources of interference, potential capacity challenges, making sure that the backhaul is performing reliably, and that you're delivering the connectivity that's required for the use case in the field. And then finally, as part of our business as a cloud platform provider, it's monitoring the core cloud platform, of course. So doing all of those things in our DevOps and network operations teams. These things are all delivered through, of course, visual tools, but also proactive triggered alarms that can be used to identify those devices and initiate very rapid response. So as we look at the specifics of the kinds of networks and the opportunities there with utilities and municipalities, one of Senet's foundational beliefs is that you need a set of flexible business models and, of course, technical tools behind that in order to meet those needs. So one of the key elements here is the ability to slide between the different kinds of networks that may be needed to be deployed in order to support those use cases. Of course, Senet as a public network operator, we primarily focus on public networks. So those are available to any of our customers that would look to take advantage of the networks that we're building around the country, as well as the public networks that our partners are building. And our partners are building those both from a pure infrastructure perspective, so they only build networks, as well as from an enterprise solution provider perspective. So they're providing solutions maybe for a hospital, putting out some indoor gateways to serve that need. And then those gateways take part in what Senet calls our LVN, or low power wide area virtual network, that connects all those different pieces of coverage together into a unified whole. So anyone is available to take advantage of that. However, in some cases, we do run into situations where customers are asking for truly private networks. So a truly private network is much more in line with what the traditional utility networks have been in the past, where it's focused really just on that one use case. So we can provide that capability where, for example, the utility, or maybe it's the distributor who is responsible for deploying that site, managing that site for the utility, or the municipality themselves, they can build out a network using our tools and platforms and keep that segmented in a walled garden for only their application. That is sometimes demanded from a regulatory perspective with local rules and regulations. Sometimes it's just a preference or historical leftover from the way things had been done in the past. But what's really powerful and what Senet can offer is the ability to merge those and blend those together in what we call hybrid networks. So that hybrid network capability allows customers to take the requirements that they might have for building a walled garden and still have their devices leverage all of the public network connectivity that may be deployed as well, or the reverse, take their network that they've deployed and bring that into the LVN to support additional use cases for which they'll get a revenue share from Senet, while keeping their devices segmented to the gateways that they've deployed themselves. And of course, once they've made any one of those decisions, they can adjust over time to fit one of the other models as it makes sense. Next slide, please. And this really forms the foundation of Senet's vision in the space for how we see, LoRaWAN really being extremely successful here in the United States specifically, but around the world, and really focusing on this key set of interesting opportunities around the utility and municipality. And there's these two components that we've talked through at length already. So first, the applications that we want to address. So certainly utility metering, utility infrastructure solutions, the smart city solutions, of which smart lighting is a very interesting aspect, and those enterprise applications that I mentioned before. And building those, deploying those on top of a network that's built up of the natural advantages of all these different parties, whether that is the utility themselves deploying on water towers, water tanks, light poles, whether it's a municipality deploying those on municipal buildings, whether it's an actual network operator like Senet going in and providing a traditional carrier grade network on cell towers and rooftops, or whether we're partnering with tower companies who are doing that and bringing in those enterprises that have deployed campus level solutions for hospitals, for higher education, and various other things. So the combination of these two elements really builds a very, very effective and a very, very accessible network for all of these different applications to come and be brought to bear. And from a Senet perspective, we really truly believe that one of the things that's been holding back smart city initiatives up till now in the IoT space has been the lack of this initial focus on the utility as the key use case to address first. once that gets addressed and once those networks are able to be opened up to the smart city applications, then there's a whole host of low friction solutions that can be brought into the market. And with that, I would like to hand over to Andy Honeycutt from MeterSys, who will dive into the details of those utility and smart city applications. Thank you.
Okay, thanks, Dave. Ken, Dave, I can't say enough about the appreciation we have for Senate pulling this together. The conversations, the partnerships are critical in informing customers and other partners about applications, so we do appreciate that. Certainly, we're excited to be a part of the team, delivering not only AMI solutions, but coupling that with unlimited opportunities for smart city applications. There's no doubt that Semtech and Senate are great partners, and you're dedicated to working with us to successfully deploy customized and reliable solutions for our customers. While our origin is AMI, both on the proprietary and the open platform environment, we really are considered an end-to-end solutions provider. So a service provider looking to solve problems. And what I mean by end-to-end is making sure that not only we do proper configuration and requirements determination, but we procure, we select, we source, and then we implement effectively with a high level of performance so that utilities get and agencies get the most from their technology investments. So we're the systems integrator, and that partnership with Senate providing us that backbone for the network performance allows us to go into the field, get our hands dirty, work with clients in developing those end-to-end solutions and making sure that they've got a reliable solution moving forward. We do provide turnkey support, so it is fully focused on being that partner and that solution provider. We are focused exclusively in the deployment of devices, networks, and applications. So those are the three critical areas of success. They have to work hand in hand, and that's our focus each and every day. And then we apply our knowledgeable team that has experience and expertise in AMI and IoT solutions. We actually operate through our metering as a service program, multiple AMI systems. So we have very deep knowledge in understanding the correlation and the importance of performance at the device, network, and application level. And then we're customer-centric, advocating on behalf of the clients. And so by being neutral to our partners and our solutions, we're able to define that criteria that makes the most sense for our customers. Okay. We have one of our brands is Synthesis, which is the smart city focus for MeterSys, and that has evolved over time. Our experience in the AMI market spans almost a decade. What we saw in the early 2000s was performance challenges with AMR. We saw battery failures, we saw the electronics failures, first gen, second gen construction that really didn't prove out and meet the test of time in terms of that harsh pit condition Remy mentioned during his conversation. And so a lot of change happened in that mid 2000s. That would be 2014, 2015, when there was a new and refreshed look at converting from drive-by reads to fixed base. And that conversion really crossed over in 2014 and never looked back, as folks realized that as manufacturers got more sophisticated in design and more defensive against water intrusion and protecting the battery health and electronic health, that became a reliable solution without really adding much by way of cost. We see in most projects that the network itself and the associated applications only add about 15% to a meter replacement project. And so if we're looking at ways to be ahead of the curve in terms of technology, without spending unnecessary and limited resources, we see AMI as creating that business case each and every time. We saw in the latter part of this decade, the early stage projects using LoRaWAN enabled systems, manufacturers getting into network as a service, really taking away the network as a focus for why AMI makes sense or doesn't make sense, but looking more at the end user experience and how we can deliver that effectively. And then we're just really excited about the emergence of LoRaWAN and our partnership with Senate in being able to deliver an open platform solution for our customers that give them either the choice of proprietary networks or the ability to open source their networks for other applications. And this really engages the departments and the agency in a much different way. Ken, if you can advance the slide, please. So when we look at the topology of the infrastructure, it's important to understand that creating that environment that supports both IoT and smart city applications is really no different than building a traditional fixed network or proprietary system. There's sensors, there's network infrastructure, a head-end system, and end-user applications, and that's it. And so we're not really creating new topologies in which to learn and master. And while there are different unique differences in how sensors are onboarded and what they require for sending data packets with transmission, the environment's really not a new frontier. And so we see that as the ability to design in a reliable and sustainable way. Next slide, please. So why are we excited about the intersection of AMI and IoT? Well, there's no question that AMI presents to utilities the opportunity to gain significant economies of scale in developing the comprehensive design. No longer relegated to just a utility infrastructure project, we can now open up the concepts of automation to practically all operations within the organization on the backbone of AMI. Most utilities are considering a meter technology change when they've reached the end useful life of their meter infrastructure, or they've gone down a path where performance is no longer acceptable. And so we have strong economies of scale, we can model that, and we're doing analysis, consistent analysis now to prove that out on the post-build, to affirm what the market says and is confident in believing that that ROI exists and that it is truly an investment, not a capital expense. We can improve revenues through read accuracy, we can virtually eliminate manual reading cost, we can standardize assets, we can conserve and provide conservation and environmental initiatives that support more global perspectives for resource conservation and carbon emissions, for example. So the network serves LoRaWAN applications for more of a shared savings and benefits, and we'll talk about those benefits in detail in just a moment. Next slide, please. So the case study is Sanford, North Carolina, and we're excited to be partnering with Sanford. They're a perfect opportunity to showcase the capabilities of technology. They're a full-service small city in central North Carolina. They operate a county-wide water utility. They operate innovatively with a focus on customer service. So their interest in advanced metering, it began around 2008 when they were researching cost and options. And then in around 2015, we conducted a feasibility study and presented those findings in 2016 on the ROI and the benefits to staff. And we'll talk about what our findings were then. But they really focused on competing for new industry, new economic development with other communities. Research Triangle Park is full of innovation and opportunity and economic growth, and Sanford wanted to be and wants to be a part of that. They want infrastructure investments that deliver clear economies of scale, not just about reading meters. It needs to be more comprehensive than that. The goals should include effectively capturing data to make better infrastructure investment decisions. So what are we going to do with the data? We don't want data for the sake of data. We want data that tells us a story or informs us to be proactive in managing our infrastructure. And the city and utility management focused on customer satisfaction. So they wanted to engage the customer in a more enlightened way. And they wanted to support those customer interactions from utility billing to environmental concern. The 2016 metering and billing findings gave us several indications that change needed to occur, and the city agreed. They had 8 meter readers covering 258 square miles. I mentioned it's a countywide system. 1,000 read exceptions per month. That's where the read in the field and what should consistently be occurring in metering and on the billing side did not align. They would send out 200 rereads per month, 375 disconnects per month, and then a multitude of tampers and customer turn-ons that never could be defended because we didn't have the data to make defensive or regulatory or oversight actions to prevent tampering and customer turn-ons. And unfortunately, they had some safety incidents that resulted in workers' compensation claims while they were battling radio failures and poor broadcast performance from those transmitters, and then the staff time associated with troubleshooting, setting issues, and radio performance that challenged the organization from a staffing perspective. So the city wants actionable data. Their focus is on, we want responsive quality data that creates for us operational advantages. And so that they can make more informed and timely decisions, whether it's diagnostic, predictive, or prescriptive. It needs to be easily configurable and accessible. Certainly they use a multitude of systems, so it needs to be compatible. It should eliminate data silos and engage the customer effectively. So for the IoT pilot for the city of Sanford, there were, we have proposed and it has been approved in the scope of work, and we've implemented 2 water meter manufacturers that will be a part of the testing environment. We also look at parking sensors through P&I, water pressure through Telog, environmental sensors and remote disconnect meter options for that initial phase and evaluation. We pull that data through a custom dashboard. Synthesis has a device data management system that we use to pull in the P&I data, not to mention the other sensor data, in order to give the city a dashboard of sorts of options to configure and to report on performance, operations, and so forth. And then we utilize the meter data management system of both Mueller and Neptune to present the read consumption data to the customer. All that is driven through network performance management that Dave mentioned earlier on the Senate network application. And so it is a continued handshake between those two systems in order to maintain that data flow. Next slide, please. So the project objectives are clearly to deliver a LoRaWAN enabled network and serve multiple meter types and do that with 100% success. And we have done that. All meters deployed, and we used propagation modeling to determine locations for test installs. That's all working very well. We want to use that network to serve the IoT devices, and that includes the parking monitoring, environmental sensors, pressure, and we also want to take that data and align it with the read consumption data for a customer portal. We want to present the collected data through customized applications and MDMS applications and evaluate the actual performance of network and devices against the model performance. So we said and felt like it would achieve these performance goals. Did we meet that, or did it play out in the field as it should? We want to prioritize the implementation strategy, and we want to develop that CapEx, OpEx forecast so that they can understand what their investments will be for a full program build out. And last but not least, and the most critical element of all actions related to networking and device deployment is communicating effectively with internal and external device audiences. So the key for Sanford is ensuring performance, and that starts with the partnerships. I mentioned the Senate and SimTech partnerships. There are a multitude of global partners that are supporting a topology for LoRaWAN that makes sense for our customer. We have to do a lot of planning in-house. We do testing in-house. We check for quality assurance, interoperability, and end-user relevance. If it's not relevant to the customer, we need to identify it and take it off the planning forecast. We need to test effectively and develop those quality programs through strict quality controls for not only device installation, but onboarding and managing those devices effectively. And then monitoring, managing performance of the sensor in the network through the applications. So the benefits are quite broad, and you see a list here. I won't go into each of these elements, but we all can understand the importance of system modernization, expandability, asset management, getting a greater handle on your infrastructure, getting in front of your infrastructure through quality controls, being compliant, regulatory and otherwise, having a financial contribution. At the end of the day, we should achieve three things. We should improve our financial condition through efficiencies and revenue. We should improve operations, and we should improve customer service. And if we hit those three things, we've effectively achieved what MeterSys considers the three primary goals of any infrastructure project, and do so safety and with a sustainable forecast. So real quick, we do have parking sensors that allow us and allow our customers capital planning and enforcement options that they do not have currently. As you know, the days of chalk tires and enforcement scans are hopefully being more automated through parking sensors and parking data. We get notifications proactively for illegal parking, whether that be space-based or over time. And then it has community benefits. It informs drivers of what parking availability exists, and so they can achieve that parking objective faster and arguably reduce carbon emissions. Water distribution controls has been a significant interest point in the market. We see that, and we're contacted quite often to look at lower cost options to scale remote monitoring of water distribution, whether it be pumps, lift stations, wells, and critical collection and distribution equipment. It does not necessarily replace SCADA for infrastructure controls, but we do see it as that alternative for sensors and other monitoring performance. It is simple and agile to deploy, and it provides the customer with more frequent and secure data updates to make better informed decisions about their distribution and collection systems. And then very topical is public safety. We're currently testing and deploying several devices that provide information on building and room occupancy monitoring, and even so fever detection. Unfortunately, this is our current environment is going to be with us. Organizations are looking at how to work in the new norm and utilizing technology to inform those decisions on whether it be occupancy or risk. And so that is a developing program of work that we are involved in and certainly can share more. At the end of the day, there has to be value and it has to be able to be articulated. AMI can serve as an anchor for enabling multiple LoRaWAN applications across utilities and city agencies. There's a business case. The backbone is quote unquote future-proof, providing an expansive opportunity for utilities and then into general operations. It does require the partner topology to make it all work. This is not plug and play. And in that vein, it requires folks that are dedicated to outcomes and that have experienced those challenges with getting disparate devices all to work in synchronization with a network and ultimately to an application. And that's through our partner network, and we're all focused on meeting customized requirements that provide the greatest level of success. So at the end of the day, we're extraordinarily proud to be partnered with Semtex, Senate, and other partners in the ecosystem to create that value proposition that, again, has to be predictable, reliable, and sustainable. And with that, I will turn it back over to you.
Great, thank you, Andy. Remy and Dave, great material, great presentations. Appreciate your contribution to this conversation. A number of questions have been submitted through the Q&A function. The majority of those have been answered and recorded. So as part of the webinar distribution, we will be sending that Q&A content out to participants as well. There were a couple that weren't answered. A few of them were around kind of the general advantages of LoRaWAN over other technologies. So cellular was mentioned, Sigfox, and other technologies. So Dave, maybe if you want to take a first stab at that, and then others can jump in as well.
Yeah, sure, Ken. Thank you. Yeah, so there's a few things that I'll comment on that were part of that Q&A. So certainly, with respect to some of those other technologies that are out there, we really see kind of two very important things with respect to the comparison against Sigfox. So one of them, when we made our decision in 2014, it was really around the openness of the ecosystem and the standards. So that's not present with the Sigfox solution. So that openness is what has created this fantastic ecosystem, and it's competitive. So you get fantastic price reductions over that period of time and a huge diversity of solutions. On the technical side, there's some really important ones. So one of the ones I mentioned was that ability to move from a coverage-based network to a capacity-based network. So we don't do that with Sigfox. And the capacity, that capability that we have within LoRaWAN is really about the dynamic control that we can in place on the end devices with respect to their RF performance. So we can continually be tuning them, changing their behavior to take advantage of better RF conditions, denser networks that are being deployed, or to dial them back and get the best coverage possible out of them. The other thing that's really important there, and again, Remy mentioned this briefly, was the ability to really have a fairly symmetrical uplink downlink communication with the end device. So again, that's not something that's possible with Sigfox. And then finally, and this really applies to both NB-IoT and Sigfox, is the ability to support mobile devices and devices that are moving at relatively high speeds. Think about on vehicles, on trains, on even potentially on airplanes and things like that. There's different reasons for that. So there's a modulation reason with respect to how LoRa modulation is different than ultra narrowband, which enables that in one case. And then in the other case, it's power efficiency. And the power efficiency for LoRaWAN is able to be affected because of the unique architecture that it has, where all of the gateways are always participating in and handling the traffic to and from those end devices in the field. So as they're moving, they don't have to reestablish control of the network or renegotiate connectivity with one of those gateways. It's all done with that centralized core. Narrowband IoT, you can, in theory, use those devices as they move from cell to cell, but it's a very inefficient process, and it becomes, in fact, less battery efficient than even LTE Cat-M1 is in those sorts of environments. So a couple of just really high-level points on that point. The other thing with narrowband versus LoRaWAN is we still are very much more power efficient. So it depends upon the exact application, but it's usually between, I would say, 4 to 10 times more power efficient than a typical narrowband IoT application is. The other question that was briefly mentioned there, which is technical as well, which is how is all of this secured? So there's two levels, multiple levels of security. Two that I'll focus on are really around the transport layer. So all messages that are delivered via LoRaWAN are secured. They are all cryptographically signed, and the integrity of that message is validated by the network itself. They are also encrypted, so those messages are decrypted at an application endpoint and at the end device that we call the application server, and that's a component of the LoRaWAN architecture that can provide end-to-end privacy. In addition to that, when we start talking about how we interconnect the core network with the application providers, with meter assist, with the metering companies, then this is again another secure tunnel that gets created between those two endpoints, mutually secure tunnel. And of course, then there are additional requirements as you start talking about the data, the meter reads, for example, that are being delivered to the end utility as well.
Great, thank you, Dave. We've got a question, probably room for a couple more questions here. We've got a question about how participants can learn more about LoRaWAN if they're a developer or a business person looking for more reference use cases. We covered a fair amount of smart city use cases here, but maybe Remy, you can jump in and discuss some of the tools and material available to folks.
Yes, I will provide in the chat some web links after that. But for developers, definitely there is a website hosted by Semtech, LoRa-developers.semtech.com. This contains a lot of material, also academy training, plus a lot of tutorial that can be very helpful, not only for developing new device, but also to understand more about the technology, like the geolocation again. And for the business guys that are looking for use cases, the important stories, where and how many devices have been deployed. For example, in France for water metering, where we see a very big acceleration with Veolia deploying 3 million of water meters. All these use cases can be found with the LoRa Alliance, LoRa-alliance.org. There is also on YouTube several webinars that illustrate in smart cities, agriculture, smart buildings, etc. So a good, I would say, list of web links that I will share with the chat. Last but not least, there is next December 3 and 4 of 2020 in Paris, the first LoRaWAN World Expo, 2 days of conferences and also a large number of exhibitors presenting innovations and their different devices and solutions. Don't miss out on this event. It will be a fantastic occasion to meet with different partners and understand more on the real stories with LoRa.
Excellent, Remy. Thank you. Thank you, Dave and Andy, for contributing to the Q&A as well. So we've reached the hour of our scheduled program. Again, we'd like to thank everyone for joining. We had a great audience participation today. Stay tuned for the recorded version of the webinar. Don't hesitate to reach out to any of us directly in the meantime. Thank you again and have a great day.